What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at lesson 3-4, which is just the introduction to writing proofs. We're going to focus on a lot of algebraic proofs and algebraic reasoning, and then day 2 will be more of a focus on all the postulates. So we're going to call this day 1 with some algebra reasoning. Okay, we're going to start with a lot of properties, so just buckle up, hang tight, and here we go. So addition property of equality. If A equals B, then we can equate that to A plus C is equal to B plus C. So notice we just added C to both sides and it created an equivalent equation, or an equation that's still balanced. Subtraction property of equality just says if A equals B, then A minus C is equal to B minus C. So again, we're subtracting C on both sides to make it balanced. The multiplication property of equality, if A equals B, then I'm going to actually write this one down using my stylus here. If A equals B, then A times C could be equal to B times C. So that means we can multiply both sides by C and it would still represent a balanced equation. The division property of equality, if A is equal to B, then A divided by C is equal to B divided by C. So again, showing that when we divide both sides by C or divide by both sides by a real number that is not equal to 0, I'm going to add that in here, we can balance that equation. C also should not be equal to 0 when we have that multiplication property of equality. The distributive property just states if I have A parentheses B plus C, then that is equal to A times B plus A times C. You can also have the difference of that, so A parentheses B minus C can be equivalent to A times B minus A times C. For substitution property, I'm going to go back to typing here because we got some words. If A is equal to B, then A can be substituted for B or B for A in any equation or expression. So that'll be true whenever we start to see a few later on, maybe not today, but for sure tomorrow when we do 3.4 day 2. The reflexive property just means kind of a mirror image of one another. A can be equal to A, maybe segment AB is equal to segment AB. You can even have, for angles, you can have the measure of angle A is equal to the measure of angle A. I know that is kind of weird, but I will show you places in which you can add that. The symmetric property really just has those flipping, so that would be more of a mirror image, I guess. So if A is equal to B, then B is equal to A. If segment AB is equal to CD, then CD is equal to AB. And then you can also have some angle measurements here. If the measurement of angle A is equal to the measurement of angle B, then the measurement of angle B is equal to the measurement of angle A. Okay, so symmetric is making that symmetry happen. The transitive property is very similar to the substitution property, except now it's more so of a domino effect, so you end up using the transitive property more often. So that one could be if A is equal to B and B is equal to C, then A is equal to C. So notice how I created that domino effect. It's almost like the law of detachment or the law of syllogism, where your hypothesis and your conclusion are matching, so then you can make that connection with your first hypothesis and your second conclusion. You can also do that with segments. If AB is equal to CD and CD is equal to EF, then AB is equal to EF, okay? You can do that with measurement of angles. It still shows the same thing. Let's say we have if the measurement of angle A is equal to the measurement of angle B, and the measurement of angle B is equal to the measurement of angle C, then the measurement of angle A is equal to the measurement of angle C, okay? So I will say, again, substitution and transitive property can kind of go hand in hand because they are representing the same thing. So when we start using reasoning for proofs, those can be interchangeable. Okay, two-column proof is where we're going to focus. A two-column proof is a common way to organize a proof. It's actually my favorite way. So on the left side of our proof, we're going to list the statements, which that is going to be showing our steps and how we're working through the problem. The right side is when we're going to list the reasons, and that's going to help us produce evidence that justifies each step. So like, why did I go from this to that? It's because I used this reason. And then our common question, what can be used as reasons? Today we're focusing just on the properties, but you can also use postulates, which is just a fancy word for properties, or theorems. And as we go through geometry, we will add on more and more properties, postulates, and theorems. These properties are the properties that we are going to focus on today. So let's turn the page and try example 1. I'm going to be able to type in a lot of this for example 1, so I'm just going to switch to typing and then I'll write for the last two. Example 1 states, I have a given of 4x minus 1 is equal to 27, and I want to prove that x is equal to 7. When you write a two-column proof, you always start with the left-hand column with your statements, 1, 2, 3, etc., and then your reasons would be on the right-hand side, matching the 1, 2, 3 with the left-hand side of 1, 2, 3. So statement 1 is your given of 4x minus 1 is equal to 27, and the reason is the given. So the next one I have says statement 2, and I've already done this next part for you, but you want to think, how did I get from 4x minus 1 is equal to 27 to 4x is equal to 28? That would be easy. I added 1 to both sides. Because I added 1 to both sides, I need to use the addition property of equality to prove that and to show that reason. So for my reason number 2, I would write addition property of equality, okay? So really you're just trying to figure out what property did I use to get from 1 to 2. Then you think about, okay, now how did I get from 2 to 3? I was at 4x is equal to 28. How did I get to x equals 7? I know I divided both sides by x, so that would be the division property of equality, okay? So as you're showing your steps with your statements, you are giving the reasons as to what property did you use. See if you can try example 2 on your own. See if you can go ahead and pause the video here, try this one on your own, and then when you're ready to check it, click play to check your work. All right, for my given statement, I have a divided by -6 plus 2 is equal to 5, so that would be statement 1 and reason 1. Statement 2, I'm switching now from a divided by 6 is equal to 3. I got there because I subtracted 2 on both sides, so this would be the subtraction property of equality, okay? And then to go from statement 2 to statement 3, it looks like I multiplied both sides by -6, so this would be the multiplication property of equality, okay? How'd you do? Hopefully you did pretty good. Let's try this one. This one is just adding on an extra step. Again, if you'd like to, pause the video here to try it on your own, and when you're ready, click play. All right, statement 1 is our given, -9 parentheses 2x minus 3 is equal to 63. To get from statement 1 to statement 2, I used the distributive property, okay? Once I used the distributive property, then I subtracted 27 from both sides, so that would be the subtraction property of equality. And then finally, I divided both sides by -28, and I got -2, but for some reason, I'm not getting that answer for my reasoning because I forgot that there was a little typo right here. This should still say negative 18. So that's your typo for notes. So make sure you fix that for now. I'm still going to show the division property of equality, and that will actually give me negative 2. So division property of equality would be my answer for reason number 4. Okay? I'm going to fix that on my sheet so I don't forget that for geometry class later. All right. Example 4. Now we're going to try something here with your example 4. Keep in mind, sometimes you won't always have to use every single line here. So I gave you 5 lines, but maybe you won't have to use them all. I want to think about what you can do to solve for x here. There are a lot of different ways. Once you solve for it, let's see how we did, okay? So what I would do first here is I'm going to try to move that 6x over to the right. So I'm going to subtract 6x from both sides. So maybe we can start with my reasoning is I'm using the subtraction property of equality. If I subtract 6x from both sides, I'm going to be left with this. 7 equals 2x minus 17. Okay? From here, I would need to add 17 to both sides. That'll be the addition property of equality. So if I add 17 to 7, I'm going to get 24 is equal to 2x. Okay? And then finally, I can solve this actually in one more step. I will be able to solve it if I use the division property of equality, because I would divide 2 on both sides, so I would get x, or 12, is equal to, oopsies. There we go. 12 is equal to x. And then if you want to, you can actually use the reflexive property. Remember, a reflexive property or symmetric property, if A is equal to B, then B is equal to A. So you could have stopped here, or you could just rewrite it as x equals 12, and we just used the reflexive property. Okay, look good? Now, I will say this. If you solved it a different way, like initially when I first solved this question, I did not move 6x with subtraction. I moved the 7 with subtraction, so I would get something completely different. I did want to show you that option as well, so what I'm going to do is I'm going to erase all of what I've got here and then show you a different way to solve this without having to fill in all 5 lines, okay? Let's say I decided instead of subtracting 6 from both sides, let's say I still started with the subtraction property of equality, but I subtracted 7. So I would end up with this. 6x is equal to 8x minus 24. Okay? Still technically correct. Then I would show the subtraction property again, because I would be subtracting 8x on both sides, so I get negative 2x is equal to negative 24. And then to solve this, I would use the division property of equality. So reason 4 is still the same, and I would get x equals negative 12, or x equals 12 right away, noticing that I have nothing else to fill in. So this would be a case where I was able to show all of my steps and make a solid proof without having to fill in all 5 blanks, okay? Let's go ahead and try example 5. This one, you might have a reason that says combine like terms. This is just proving your work, okay? So one of the reasons could say combine like terms. Let's go ahead and pause. Try this one on your own. And when you're ready to check it, click play. All right, statement 1. For my beginning statement, what I would do is I would show the distributive property. So here I would distribute negative 7, so I get negative 7x minus 14, and then plus 4x is equal to 6 times 2x is 12x, 6 times negative 4 is negative 24, okay? Once I have the distributive property, step 3, or my reasoning for number 3, is I'm going to combine like terms, okay? This one is not a property, but it is still showing where we can combine certain numbers, and that's kind of just like my in-between step between step 2 and step 4. So negative 7x and 4x can come together and be combined to negative 3x minus 14 is equal to 12x minus 24. Now I'm ready to go right back into some other properties. I'm going to do the, let's see, I'm going to do the addition property of equality. I'm going to add 14 to both sides. So I would get negative 3x is equal to 12x, and then 14 added to a 24 is negative 10. And then I would do subtraction property of equality. And I would be subtracting 12x from both sides. So 12x subtracted from negative 3x is a negative 15x, equaling negative 10. And then my final step would be the division property of equality. And I'm going to divide both sides by negative 10, which would then give me, divide both sides by negative 15, which then would give me x is equal to 2/3, okay? Again, there are other ways to show this. Maybe you didn't add 14 to both sides. Instead, you maybe added 24 to both sides, and you still could have used that reflexive property like we did up here, because reflexive property, so the symmetric property, if A is equal to B, then B is equal to A. I think we might have said that wrong. So initially when we had this here, 12 is equal to x, and we wrote, to get to our next reason, we said x is equal to 12. That would be the symmetric property, okay? Because you're going from, remember, symmetric property is A is equal to B, B is equal to A. Reflexive is A is A, B is B. So might have messed that one up, so just think about that one in the future. That's all I have for today. We'll go through this on day 2. Thanks so much for tuning in, and hopefully this gives you a better idea of some algebraic reasoning with proofs. Have a great day. Bye.